mathletes, ready to tackle more complex numbers? This video is your complete, step-by-step walkthrough for exercise 1.3. We'll make these complex problems simple. Let's get started. Rewrite. We rewrite the expression as a difference of squares by using I. 2 equals 1. Steps. Z. 2 plus 169 becomes Z. 2 minus 169, then Z. 2 minus 169 I squared. Factor. This factors into Z. 2 open parenthesis tuition thin. Final linear factors. The solution is open parenthesis Z plus 13I close parenthesis times open parenthesis Z minus 13I close parenthesis. Factor constant. First, factor out the common term 2. We get 2 times open parenthesis Z. 2 plus 9 close parenthesis. Rewrite. As before, we rewrite the sum of squares. Z. 2 9I 2 or Z. 2 minus open parenthesis 3I close parenthesis squared. Final linear factors. The solution is 2 times open parenthesis Z plus 3I close parenthesis times open parenthesis Z minus 3I close parenthesis. Rewrite. We rewrite the fraction as a square. Z. 2 plus open parenthesis square root of 3 over 5 close parenthesis squared. Difference of squares. Use I. 2 equals 1 to get Z. 2 minus open parenthesis square root of 3 over 5 close parenthesis squared I squared. Final linear factors. The solution is open parenthesis Z plus square root of 3 over 5 I close parenthesis times open parenthesis Z minus square root of 3 over 5 I close parenthesis. Trial root. We test for rational roots by testing Z equals 2, 3. We find that P of minus 3 halves equals 0. Factor theorem. Therefore, Z minus open parenthesis minus 3 halves close parenthesis, or Z plus 3 halves, is a factor. This means to Z plus 3 is also a factor. Synthetic division. We use synthetic division with the root minus 3 halves to find the remaining quadratic factor. The coefficients of the depressed polynomial are 2, 0, and minus 10. Quadratic factor. This gives the quadratic factor to Z. 2, 10. Simplify and factor. Factor out to from the quadratic. 2 times open parenthesis Z. 2, 5 close parenthesis. Final linear factors. The final factors are append Pinterest on trial root. We test Z equals 1. Since POF 1 equals 0, Z1 is a factor. Synthetic division. We used synthetic division with the root 1 to find the quadratic factor. The coefficients of the depressed polynomial are 1, 1, and 6. Quadratic factor. This gives the factor Z. 2 plus Z6. Factor quadratic. We factor the quadratic normally into open parenthesis Z plus 3 close parenthesis times open parenthesis Z to close parenthesis. Final linear factors. The solution is open parenthesis Z minus 1 close parenthesis times open parenthesis Z plus 3 close parenthesis times open parenthesis Z minus to close parenthesis. Trial root. We test Z equals 3. Since POF 3 equals 0, Z plus 3 is a factor. Synthetic division. We use synthetic division with the root minus 3 to find the quadratic factor. The coefficients are 1, 1, and 20. Quadratic factor. This gives the factor Z. 2, Z20. Factor quadratic. We factor the quadratic into open parenthesis Z5 close parenthesis times open parenthesis Z plus for close parenthesis. Final linear factors. The solution is open parenthesis Z plus 3 close parenthesis times open parenthesis Z minus 5 close parenthesis times open parenthesis Z plus for close parenthesis. Factorization. We look for 2 numbers that multiply to minus 8 and add to minus 7. These numbers are minus 8 and plus 1. Factor by grouping. We rewrite the middle term. Z. 2. 8Z plus Z8. Final linear factors. The solution is open parenthesis z minus 8 close parenthesis times open parenthesis z plus 1 close parenthesis. Factorization. We look for two numbers that multiply to 4 times minus 11 minus 44 and add to minus 7. These numbers are minus 11 and plus 4. Factor by grouping. We rewrite the middle term for z, 2, 1z plus for z 11. Final linear factors. The solution is open parenthesis for z minus 11 close parenthesis times open parenthesis z plus 1 close parenthesis. Isolate. Move the constant term to the right. Z, 2, 6z equals 2. Complete the square. Take half of the z coefficient, which is 3, square it, which is 9, and add it to both sides. Z, 2. 6z plus 9 equals to plus 9. Factor. The left side factors to open parenthesis z minus 3 close parenthesis squared equals 7. Square root. Take the square root of both sides. Z minus 3 equals plus or minus square root of 7. Solution set. The solution set is open curly brace 3 plus or minus square root of 7 close curly brace. Clear fraction. Multiply the entire equation by 2 to clear the fraction and make the leading coefficient positive. Z, 2, plus 1 OZ for equals 0. Isolate. Move the constant. Z, 2, plus 1 OZ equals 4. Complete the square. Take half of 10, which is 5, square it, which is 25, and add it to both sides. Z, 2, plus 1 OZ plus 25 equals 4 plus 25. Factor. The left side factors to open parenthesis z plus 5 close parenthesis squared equals 29. Square root. Take the square root of both sides. Z plus 5 equals plus or minus square root of 29. Solution set. The solution set is open curly brace minus 5 plus or minus square root of 29 close curly brace. Normalize. Divide the entire equation by 4. Complete the square. Take half of the z coefficient. Factor. The left side factors to open parenthesis z plus 5/8 close parenthesis squared equals 25 over 64 plus 7 halves. Common denominator. Find a common denominator of 64 on the right side. The right side simplifies to 64. 249. Square root. Take the square root. Z plus 5/8 equals plus or minus square root of 249 over 8. Solution set. The solution set is open curly brace minus 5 plus or minus square root of 249 all over 8 close curly brace. Complete the square. Take half of minus 5, which is 25, square it, which is 425, and add it to both sides. Z to 5z plus 425 equals 3 plus 425. Factor. The left side factors to open parenthesis z minus 5 halves close parenthesis squared. The right side simplifies to 13/4. Square root. Take the square root. Z minus 5 halves equals plus or minus square root of 13 over 2. Solution set. The solution set is open curly brace 5 plus or minus square root of 13 all over 2 close curly brace. Clear fraction. Multiply the equation by 2. Z, 2, plus 6z 32 equals 0. Identify coefficients. We use the quadratic formula with equalson, b=6, and secals manushrity 2. Apply formula. The solution is put close parenthesis Simplify. The discriminant simplifies to 36 plus 100 y8, which is 164. Final solution. The solution set is open curly brace minus 3 plus or minus square root of 57 close curly brace. Note, the solution set in the image has a potential error in simplification as 164 equals 241. But the method shown is correct. Identify coefficients. We use the quadratic formula with equalson, and secals 17. Apply formula. The solution is Simplify discriminant. The discriminant simplifies to 1/4 minus 68, which is minus 271 over 4. Use I. We replace the square root of the negative number with I times the square root of the positive number. Final solution. The solution set is open curly brace 1 plus or minus I times square root of 271 all over 4 close curly brace. Identify coefficients. We use the quadratic formula with A equals B equals -6 and C equals 25. Apply formula. The solution is 5 close parentheses lol. Simplify discriminant. The discriminant simplifies to 36 minus 100, which is minus 64. Use I. The square root of minus 64 is 8i. Final solution. The solution set is open curly brace 3 plus or minus 4 close curly brace. Elimination method. We aim to eliminate one variable, in this case, z. Multiply. Multiply equation 1 by 2 and equation 2 by open parenthesis 1 minus I close parenthesis. Subtract. Subtract the new second equation from the new first equation to eliminate z. Solve for w. Isolate w. This requires multiplying the numerator and denominator by the conjugate of the denominator, 9 minus 5i. W result. After simplification, w equals open parenthesis 53 plus 7 I close parenthesis over 53. Substitute and solve for z. Substitute the value of w back into the original first equation. Z result. Isolate and solve for z. The final result for z is 155 over 106 plus 145i over 100. Rearrange. Distribute the I in the second equation and move terms to align with the first equation. Elimination method. We will eliminate w. Multiply. Multiply equation 1 by open parenthesis 1 minus 2 I close parenthesis and equation 2 by 2i. Subtract and solve for w. Subtract the new second equation from the new first equation to solve for w. W result. After complex algebra, w equals open parenthesis 199 plus 177 I close parenthesis over 205. Substitute and solve for z. Substitute w back into the original first equation and solve for z. Z result. The final result for z is 373 over 205 plus 36i over 205.